Welcome to a new video in my home automation series, and today I can finally give you an update on my access control project using this RFID scanner and this ESP module, and finally my PCBs from PCBWay have arrived as well. So everything should be working now, and I made a few enhancements since you saw the code last time. Well, first enhancement is I received my I button reader, and I also have some couple of I buttons, and I've integrated that one as well. So you can choose which one you find more convenient, a keypad with the RFID reader or the I button. And I also connected this 4-relay board. The idea is that I'm going to use it at my gate. So obviously I can punch the code and then I can use the relay to open the gate or open the door, and maybe I can use the other inputs, the other outputs to turn on lights, something like that. And I also have one input configured, and I think I had that even at last time. And the idea behind the input is I want to be able to detect whether the gate is open or not. So if the gate is left open, then I can, do some notification, or, after 15 minutes, maybe I can just close the gate automatically, something like that. But actually, I'm thinking that I might need more inputs after all. So I might change the design. I mean, the PCB is already made, but I think I can just quickly adapt it using some bodge wires or mod wires, and maybe only use 2 relays and then use the 2 other pins as inputs. So I can get some more inputs. Well, it will depend on the scenario, so I will see how it goes. And of course, the PCB was manufactured by PCBWay, so thanks PCB for that. And so I also want to mention that I haven't done it yet, but this PCB is going to be on the PCBWay project site. So I will probably do it in the evening or maybe tomorrow. But I think I'm going to release the video, and then after that I will include, the download links, how you can get the PCB, how you can download the Gerber files, or just probably the simplest way is just you can order them from PCBWay. They are fairly, small boards. Maybe they are just a little bit bigger than the smallest board. So it might not be, $5 US, maybe it will be 10 plus shipping. But I think it's certainly, quite cheap, and well, definitely looks a little bit more professional. So I'm going to look at the PCB in a little bit later. But if we go back to the model, so, well, actually I need to turn it on. Okay, everything is working. So what you can see here is obviously I was meant to use the VMOS D1 Mini, but for some reason I ended up with the Node MCU, and only now I realized that there is no point using the Node MCU because there are hardly any pins on the Node MCU that would use in a regular project. So I think I will go back to using VMOS D1 Minis in the future. So in terms of the inputs and the outputs, let me get a pen, something like that. Okay, so these are the 2 outputs for the RFID module. And by the way, in the sales screen, they are labeled, but it's just a little bit hard to see because they are right next to these screw terminals. But anyway, so it says that this one is the white, this one is green. And on the next terminal, we have the I button reader. And I purchased this model, which has the built-in LED. I think it just looks a little bit better, and this looked to be like a waterproof version. So it was a little bit more professional for me. So it has a couple of inputs, or a couple of connections. It has 2 connections for the reader, and there are 2 connections, which is basically the relay. And I think this resistor is the series resistor for the LED, the red LED that you can see here. And then these 2 inputs is going to be the analog input, so I just have a simple button connected. This is the 12-volt input, and I decided that I'm just going to use a 7805, LM7805 linear voltage regulator. So these are the 2 caps that are needed for that. But in fact, I think I'm going to change my mind, and I've already ordered these buck converters, 10 of them, and this is the version where you can change the output voltage by soldering these connections on the other side. So I think I'm going to use this one, and the good thing about this that it has the same pins and as the voltage regulator. So the voltage in is on the left, and then ground is in the middle, and then voltage out is on the right. So I mean, if I flip it this way, it's going to be the exact same pin out as the linear voltage regulator, and it also has an enable pin, but you can just leave that floating. So you can use a linear voltage regulator and the two caps, 33 micro and I think it's 10 micro, or you just leave the caps and then you can use this one. Actually, I think the reason I'm going to use this one because I'm going to be mounting in a case, so I'm just concerned that that's going to generate too much heat and it's going to get too hot. But we'll see. So that was the power input. So at the moment it is powered from 12 volt. Let me just check. Yeah, it is getting warm. These 6 pins are the same pins that are needed for this relay board. This is a generic relay board that I ordered from AliExpress a long time ago, so I don't have a link for that. But that's has the opto-isolator, which I do like if it includes an opto-isolator, and it is active low. And the relays are 10 amps, which is probably a little bit overkill for opening a gate, like operating a the gate motor. But if I think for my normal passenger gate, I'm going to use a magnetic lock. That probably draws a couple of amps, and also if I want to use lights, they might draw a few amps. So actually, I think I'm going to use this one. I have those models where they have solid state relays, but I think that's only good for 2 amps. So probably this 10 amp model is going to be better. So that's connected here. So it has the same connections, 5 volt, ground, and input 1 to input 4. I label them as input 1, 4. Of course, it's an output here, but it has the same labels what you find here on the relay board. So that's the relay, or 12 volt coming in here. So obviously the 12 volt goes to the RFID unit, and it also comes here. And then finally the NeoPixel LED that I'm using just for status purposes. Oops. And I have this model that I ordered from Banggood ages ago, and I just like it because it has a small PCB, so it's easier to solder, and that's it. And I use these wires. So obviously green is data, red is 5 volt, black is ground, and it's connected like this. And again, the colors are shown in the silk screen. And by the way, this is how the PCB looks like. And on the other side, you can see the silk screen and the markings, but they are just really, really small. I don't know if my camera can focus that much. Probably can't. Anyway, okay, so that's the PCB. I've gone for the yellow silk screen. Looks nice. This is my first yellow. I'm quite happy with it. So that's the PCB. Oh, by the way, one more thing about the PCB. I don't know whether it was only my batch, and this hasn't happened with me with PCBWay, but it was really difficult to solder the ground connections. So I don't know, maybe there was some residue on the pins, sorry, on these solder points. So I just needed to just clean it with alcohol, which I usually don't do, and then everything was fine. So, but this is the second one I soldered, and it was the same for both of them. Maybe it was something with a batch. I'm not really sure. You can see the linear voltage regulator pins here, so that's where the buck converter would go as well. Okay, going through the general workings, I guess. I mean, well, the usual thing, you can scan your RFID. So that RFID was linked to a valid user. So you can see the green LED. If I use a different RFID, which I don't have here at the moment, but let's say I just punch a random code, then I get reds saying that that wasn't a valid ID. And now I also have the I buttons. So I just scan it. I mean, I'm not really sure which I like better. It's probably the only reason I like the RFID because it beeps. And of course, this doesn't have a beeper inside, but this is much smaller. So, but that's one more reason to use it. And of course, these are really easy to carry around as well because they have these tabs. To be honest, I know that these RFID tags can be modified. So the code on them can be overwritten. I'm not sure about these, but I think these could be rewritable as well. So in terms of security, I don't think these iButton tags are any more secure than the RFID ones, or at least these versions. So, you know, if you are concerned about security, definitely keep that in mind. And now let me look at the code, or let me show you the code. So that was PCBWay. Thanks again, PCB, for this video, or sorry, for this PCB. And so I've made some changes to the code as well, but the core of it was already there. Obviously, what I have added to the sketch is that it handles the RFID as well. I think I already had the relay logic and the input logic implemented before, but maybe that's something that I've also added since then. And as you can see, the top of the flow is pretty much the same. Of course, this user ID validation and the event ID validation has been updated because now they also need to handle the RFID. Well, actually, no, they don't have to, because I've written the code that it can handle any authentication method. So whether it's, you know, keypad or RFID or iButton. So that hasn't changed. But there is one more thing that has changed is I've changed how I handle the active status. So let me show you this one. If you remember, this is the JSON how I initially set up the configuration, like the users. And previously we had a mode, and I think this mode was either showing active or blocked. And I think I modified that to active or disabled. And there is one more option here as well, which is one time. I think it's called one time. Anyway, we are going to look at it when I go to the UI. So the additional thing that I've added is there is also a burner code. So you can create a user. Okay, sorry, not a burner code, but a burner user. So you can create a user and you can give it the mode, which is, I think it's called one time, which basically means that when it gets used for the first time, it automatically gets set to blocked. So you can give one-time access to somebody, you know, with a code, which can be any of the codes. The other thing I've modified is that I had this user management section where you can modify the user data. I think it was missing a couple of fields, and I made some, you know, fixes to the code, but it was mainly there before. And I've also done the same for event, which is, you know, it's almost the same. Some of the fields are a little bit different, but other than that, it's the same stuff. It's manipulating two different objects, but it's pretty much the same. Let me check the mode. Oh yeah. So as you can see, the mode can be either active, one time, or disabled. So if you set it to one time, it will automatically get set disabled once it is used. And of course, I just created these simple, you know, push buttons to test the and I've created this simple push button, so I can test the relay. So I can turn off the relay, and yeah. One thing to keep in mind is relay 1 and relay 2 are connected to ESP pins, which do not go low when it boots up, but pins 3 and 4 are pins when they go to low. So if you connect them to a gate or something, then they will open if the ESP gets rebooted. So only use relay 1 and relay 2 for gates, and 3 and 4 should be something else, like, you know, lights or something else. So that's something important. I mean, unfortunately, this is how the ESP works. You can't do anything about that. If you want them to use as outputs, some of them have default low status when the device boots. And you can send an on-off value, 0 or 1. to the RFID/relay 1, relay 2, relay 3, and relay 4 topic. Of course, you can define these topics in the Arduino sketch, but on top of that, you can also send pulses. So let me turn off the outputs. And by the way, this is something that I also need to figure out is, oops, there is something on, I think that I have some connection issues on relay 1. It shouldn't be doing this. Okay, so there are some temporary connection issues, but I've also created 2 more topics, which is called the pulse 1 and the pulse 2, and they like momentary ons. So if you do this, yeah. So typical garage door openers or gate openers, you know, the motor controllers, they just need a short input. So you don't have to send 2 signals to turn it on and off. You can just send a pulse and then it does the thing. And I've already done it for output 1 and 2 because, as I said, you shouldn't be using this for output 3 and 4. And I also have a topic for the input. So if this input switch gets pushed, we can see that it sends a 1 and a 0. So this would be the feedback for the gate state, whether the gate is open or not. And now I realize the other reason I wanted to have another input, because maybe I'm going to use these to replace my RF doorbells as well, which, you know, they tend to run low on battery and you can't really figure out whether your doorbell is working or not unless the postman tells you that he was pushing the button and nobody came. So that was the thing on the flow. And if I look at the UI, let me just go to the UI and select, what is it? I think it's called access control. It's called access control, yes. So, and so yeah, you have the users, you can select the users. Now they show the status and everything, and you can select those statuses that I talked about. It also shows now all the IDs that are assigned to these users. One thing I haven't done yet is I haven't implemented the function where you can delete an ID. So it's not possible yet, but I have added the functionality to add an ID. So what I can do is, for example, if I set, so this is a new I button, which I think I haven't used yet. So if I use this, no, it is also assigned to dad. Oh, maybe it's the blue one then. No, that's also assigned to somebody. Okay, no, that's assigned to mom. So, but what you can do, so this is assigned to mom. No. Let me do it with a code. So the dad has a pin code of 2233. Let me create a new pin code. So first of all, I type the pin code, like I don't know, 4567 hash. So now it says that the pin is unknown, and it remembers the last code that came through the whole flow. And you can click the add last ID and it gets added to the user ID. Oh, I guess I need to do some refreshing here, because if I select dad, now he is also assigned to 4567. So if I try again, 4567 hash, now we got a green, and we can see that dad was successfully identified with a pin of 4567. And you can do the same with the events as well. So you can select the, you know, this is the event. You know, there is a event, you know, I've created 2 events. They are pretty much the same. They have names and access level. The mode obviously doesn't have a one time, well, obviously or not, but it doesn't have, there is no one time here. And the same days of the week, time, from, and the IDs. And of course, you can use any IDs here as well. And the rest of the reporting and the logging hasn't changed. So you can still do the same. And now you can also filter on I button types. So it only shows you the I button ones. So I think that's it. As I said, well, probably the flow can, you know, do some TLC and then, you know, just a little bit more testing. Well, some more testing just to iron out some of the scenarios. For example, when you change something, this part of the screen gets reset, and I just realized that the ID list doesn't get reset, so probably that should happen as well. The Arduino code is, I think that's pretty much final, so I'm going to upload the new version on the GitHub, so you will find the GitHub link in the video description. Also, the link to the Gerber files or the PCB is going to be there, so you can order your own PCB. I'm probably going to update the listings as well. I think I already have the listing for this one. I will find the listing for this I button. And as I said, the relay board, you just have to pick a relay board. Usually they all work the same way, so it doesn't really matter what type you go for. But these blue ones are very common. And yeah, there is nothing else, special about that. And of course, yeah, you have to figure out the voltage, the 5-volt thing, whether you want to use an LM7805 with the 2 caps, or you want to use this buck converter. And I'm going to leave the link for this one in the video description as well. I only received it a couple of days ago. I haven't even tested them, but I'm pretty sure they work. And I think they can handle 1. Oh, it says here actually, or the other side. Oh, no, it was in the listing. So anyway, they are up to 1.3 amps. So that's, more than enough what is required by this unit. And I mean, with this whole heatsink, it is warm. It's not hot at all. So you can use a linear voltage regulator as well if you have enough ventilation around. I'm just concerned that being in a smaller case, it's probably going to be too hot. But that will be all for today. Oops. Thanks for watching, and hopefully see you in the next video.